Hi, so in this video on Idiomatic Python, I want to talk about decomposition. So here I'm mainly going to talk about functional decomposition, but the same principles really apply to classes as well. And far too often I come across code during code reviews or just things that I see online that contain functions or classes that just do way too much. It makes the code very hard to read and maintain, and also very hard to unit test, because the more complicated a function is, the more branching it has, the more tests you have to write. And it makes it very, very difficult. So it makes it hard to debug, to know if there's something going wrong in the code somewhere, difficult to read for somebody else coming in and looking at that code. Basically, it's a steaming pile. Now, this isn't unique to Python, by the way. This should be part of Pythonic coding best practices, of course, but it applies to any other language as well. So just to show you an example, in this video, we're going to look at one such function that does a lot of stuff, and we're going to fix that. So let me just show you what that looks like. Okay, so this is a function. I'm going to come back to it and explain to you what it is. But I urge you to actually maybe pause the video, get the link from below in the description, and go look at this function and see if you can figure out what it's doing. Right? But we have this function here, and as you can see, it's got a bunch of stuff. It's got a while loop, it's got some tries, and then it's got some other stuff, then it's got a for loop, then it has another for loop, and in there it's got another while loop. And it's doing a bunch of stuff. And at the end of the day, we then print out some result. Okay. So this code, I think, is mostly correct. It actually does what I'm wanted to do. But trying to understand what's going on here, trying to debug it, it's horrendous, right? And yet I see code written like this all the time. So there's a certain set of kind of rules that you kind of follow when you're writing functions. And I'm sure I'm going to get arguments about it in the comments. And by all means, share your thoughts. But with 20 plus years of experience writing code and having read quite a bit of what other people say as well, I think this kind of encapsulates it pretty well. Your functions should be relatively short. They should be measured in tens of lines, not hundreds. If you've got, functions with hundreds of lines, that's just too long. Functions should have a single purpose. They should be doing one thing and one thing only, and the function name should clearly reflect what that purpose is. Makes it much easier for somebody reading the code. Now, the code inside a function should be at the same abstraction level. It shouldn't mix low-level detail work with higher-level calls to other functions. And you'll see what I mean when we actually look at the code. You'll see an example of that. The code should be, the function should be easy to unit test. As I mentioned, more branching code makes it more difficult to test, since you have to test not only each branch, but all the combinations of these branches. So that just basically blows up the number of unit tests that you have to write. Your functions should be properly documented. You should have something, maybe doc strings, maybe type hints, worst comes to worst, maybe just comments. But at least document, what does the function do, right? What is its goal? At least do that much. There shouldn't be commented out code. If you've got, commented out code in your function, that means that you're still in development mode. You're trying things out, you're removing code, but you don't want to delete it quite yet. But once you're done, that code has to go. And this is why we use version control software like Git, for example. So we don't have to maintain old code in comments. Get rid of it. It's just, it looks messy, and it detracts from the rest of the function, the rest of the code. And now, as someone reading the code, you got to kind of jump over it, but then you might get distracted. It's like, well, what was it before? What's going on? Just get rid of it, right? It doesn't belong there. It should be gone. There shouldn't be dead code. You shouldn't have unreachable code in your functions, obviously. And also, very importantly, it should be straightforward to understand the code in each function. Don't use magic tricks and, what I like to call arcane incantations that hides and obfuscates how the code works. Some people love to do that. They love to write complicated meta classes that hides everything from you. Now, as a developer, you're trying to figure out, well, how do I do this? Where is this piece of information coming from? I can't tell you the number of times I've worked in certain libraries. I'm not going to mention their names, but I've worked in certain libraries and I have no idea where certain pieces of information, certain parts of the state that I'm working in a class even comes from. I can't track it down. That's horrible. That makes it very difficult to understand, very difficult to work with. Now, one other thing too that you'll see is that some people say that the function should not have any side effects. And I guess my take on this is it depends on what is meant by side effects, and I don't entirely agree with this one. I think if you're a functional purist, you're going to insist on this, and I understand that, I get that. But Python is not for purists. It's got a mix of, semi-functional, language. It's got a little bit of object-oriented. It's a very practical language. And the Zen of Python really, states that pretty explicitly. Practicality beats purity. So, actually, in the context of writing Python code, I think, you probably should do this, import this, and just read the entire Zen of Python, because a lot of that is basically dictating how we're going to refactor that horrible function that I just showed you. So I think it's okay for a function to have certain side effects sometimes. I'm not a purist when it comes to that. And for example, a function that acts as a logging decorator does two things, right? It runs and returns the value of some function call, but it also has a side effect of writing logs out somewhere. That's perfectly acceptable in my mind. And I don't honestly see a way around it anyways. Now, on the other hand, a function that mutates one of the arguments that get passed to it, that I don't like. Especially if that function also returns a value. I would never do that. I would never write a function that both returns a meaningful value and mutates one of the arguments that you can pass to the function. I would never do that. Now, I might be okay with a function that mutates an argument's state as long as it doesn't return anything meaningful. But even then, I might argue that you may just need to redesign your code a little bit. Because generally, I think functions that do that mutate state, should probably be methods in a class where you're mutating the instance state. I think that's okay. We see that all the time in Python. Like if you have a list, you can do in-place sorting with a list by using the sorted method. But if you use the sorted function in Python, it doesn't mutate the list. It returns a new one, right? So that's the kind of thing that I'm talking about. All right, so let's actually now go back and look at that example, and we're going to start refactoring it. So I have a function which, given some arguments, queries an API for some data, transforms that data in some fashion, and returns the results. That's what that function does. I happen to use the Star Wars API. It's free. It doesn't require us to use an API key. And hopefully it's around for a while so that this video doesn't become totally useless in a short period of time. Now we are going to need to handle paging because it uses paging, and one of the API calls that we make is going to require paging, so we're going to do that. The other thing too is that it's fairly frequent to get timeouts with this API. It's public, it's free, it's got no authorization required, so timeouts can happen relatively frequently, so we need to account for it. So let's start with the bad code, right? It's a horrendous single function approach that would basically, if it was to hit a code review in any decent software development team, the person, isn't even going to read the code. They're going to say, no, just go refactor that. Now, you might say, but it works. Sure, it works, right? But it's almost impossible to understand that code, and testing it is going to be really difficult. Let's take a look at it. So this is the function. We are going to get the Starship films with a min capacity. Whatever that means, right? I don't have documentation here that explains what that is. And now I've got code comments that says, oh, query the API with retry if timeout happens up to some max number of times. Okay, that makes sense. So we've got a bunch of code. We're going to hold ships in here. We've got this request URL, which is default to the first page. I'm not quite sure what that means. Okay. Oh, there's a while loop, an infinite while loop. And then in here, we test the number of retries. So, okay, so we're trying to retry something here. Okay, that must be the timeout problem. We query the API with a specific page. Well, what's the specific page? Well, it's the request URL. Okay, well, okay, it's that one, which is the first page. All right, fine. So it does a GET request. It does a raise for status. So if it doesn't come back as, you know, a 2xx HTTP status code, it's going to create an exception. We catch a timeout exception. Okay, so this is where the thing is happening. So we catch a timeout exception when we do the request GET. And if it times out, we increase our current timeout by multiplying it by 2. So it used to be 0.5. Okay, and then we set our attempt number. We increment that by 1. Then we continue. So this means we go back to this while loop. Okay, and now we check the attempt number. Okay, I get it. It's basically running this again because there was a timeout. Okay, so assuming there's no timeout, if there was a request exception, it just returns. So basically it fails the app kind of silently because it doesn't raise an exception, it just returns. Okay. Here we get the data from the JSON response. Okay. We get this results thing and we extend it. So this results must be the ships, right? So we then extend our main ships over here with whatever came back. But why are we doing that? Oh, because there could be a next page. So if the data contains a next in there, that means that there is more data and the next happens to contain the request URL that you need to call to get the next page. And then we set our current timeout to the initial timeout. So this is good having this over here because it says reset the retry count and timeout. We start fresh for each page. Yeah, that kind of makes sense, right? We want to start with our original timeout and our attempt numbers reset back to 1 for the second page and then the third page and so on. And so what happens? Well, it goes back to the while and it's now requesting this new URL, right? Because we set the request URL over here to whatever was in the next page. Okay, so this whole thing over here basically is running this query, this GET query for the API starships, and it's doing two things. It's handling retries if there's a timeout, and it's handling multiple pages. So it's doing kind of two things. So you can see here that the actual kind of business logic in here is this GET request, right? And then grabbing the data from the request. Everything else is plumbing. It's handling timeouts and retries. It's handling multiple pages in the API. All that is what I consider plumbing. It's not really focusing on what this piece of code does, which is get all the starships, right? So now that we've got all the starships, what's happening? So now we find all the ships with a minimum cargo capacity. So ships in the ship API have a cargo capacity, or they may have a cargo capacity, and we basically want to filter it based on some minimum capacity. So we have the film URLs. That's because the API, if you go and look at the Star Wars API, you'll see that it returns, and let me actually just show you that. So let's jump to the documentation and let's take a look at starships. So if you look at the example response for a starship, we get back, remember this cargo capacity that I talked about, and then we also have which films this particular ship showed up in or is seen in. And what I want is to get a list of all the movies that contain ships that have greater than some specific cargo capacity, right? Essentially. So going back to the function. So here basically we've got all the starships. Now we're filtering them out. So we're looking at the cargo capacity. make sure that it's there. So if we get a key error or value error, we're just going to basically ignore the fact because we couldn't get a numeric cargo capacity, so we're just going to skip the ship. And if we do have a cargo capacity and it's greater than or equal to the min capacity, we're going to update the film URLs, which is a set. So we're going to update it with whatever's in that list of films, because that was a list. And the reason that this is a set here, I guess, is because we don't want duplicate films. We don't need to maintain duplicate films. Okay. So now what's the next step? Well, fortunately, we have a comment that tells us what this next section of the function is. And by the way, this is a very clear indicator. When you're reading a function and the developer felt that they needed to write a comment describing each section of the function, that is a dead giveaway that the function's too large, right? You don't need to be doing that. Okay, so now we have the film titles, and that's what we want to get at the end of the day, is the film titles for every film, right, URL. So remember that if we look back at here, the films is given by a URL. So we can query the API at this URL to get information about the film. And when we do that, we will get some information about the films. In particular, we're going to get something called the title, which is over here. So switching back to the code. So for every film in the film URLs that we've collected, we again do this whole thing with a temp number, then we have a try, then we've got a while loop. Yeah, that's because we need to handle the retries. So this is the whole retry logic happening here. Here's the real meat, right, of what's going on. We're making a request to get that film, and then we're getting the title from the film, and then we're adding it to the film titles set. Okay, and everything else is basically plumbing. So we've got a stop iteration, and we're catching a stop iteration. Why? Are we raising a stop iteration somewhere? Oh yeah, look at this. We're raising a stop iteration over here. Why? We don't want to abort the call. We'll just skip this film. Okay, this is because maybe I was unable to query the title for that particular film, but I don't want to break the app just because of this. I'm just going to skip the film. I disagree with that. I think that if something goes wrong, this is probably silencing an exception, and I don't think it should be silenced. I think it should bubble up and let whoever is calling this function decide what they want to do, right? Instead of having the function itself make that decision, we probably should just let the exception bubble up. But you know, again, it kind of depends on the use case, but fair enough. Okay, that's the function, and then this is what we do. We call starship films with a minimum capacity of 1,000. So we're looking for all the starships which have at least 1,000 capacity, and then we want to find all the films that those ships show up in, and we just want a list of those films. So we can run this. You'll need, by the way, to install, if you're going to run this as well, you'll need to install the requests library in your virtual environment. So let's go ahead and run this. So you can see we're getting some request timeouts. It's trying again. You can see that it's paging, right? So we've got all the paging going on. And now it's requesting the films. And at the end of the day, here's what we have. So these are the films that contain starships with cargo capacity greater than or equal to 1,000. All right. So as you can see, this is a mess, right? Yeah, it works. I get it. It works. But nobody wants to read this. Nobody wants to debug this. Nobody wants to maintain this. So let's start refactoring. So the first thing I'm going to do is to break out the code that actually queries the API. I'm going to create a service module, and I may even create a package. And actually, I will create a package because maybe I'm going to have multiple services to contend with. But irrespective, in this case, I'm going to do it. I only have the one service, which is going to be the SW API or the Star Wars API. I'm also going to create a main.py. That's the standard name for an entry point for a Python app. If you use main.py, everybody knows, oh, okay, this is where I launch this particular application, main.py. Okay, so I'm going to keep the changes pretty minimal and just try to break that huge function into smaller chunks first. I am not going to try and refactor everything at once. That is going to be just too difficult, right? Even with just that single function that we saw, trying to refactor it and doing everything at once is just going to end up being a mess. Okay, so let's jump in and actually do the refactoring. So I'm going to call this Refactor 1. And for there, I'm going to create another module, or package, I should say. It's an implicit package. I'm going to call that services. Services, if I can type. Then under that, I'm going to create another module, another package, or sub-package called SWAPI for the Star Wars API. So if I've got multiple services, I would build them each one underneath. Now for now, this is going to be just a single file. I'm going to call it the api.py. And let's go ahead and look at our main thing over here. So I'm going to create another file here. I said I would create a main.py. Okay. So let's take this entire thing and let's paste it into main.py. And let's see what we want to do. So I'm going to remove this as a perfect example of how not to write code. And I'm just going to document it as that. And let's see what we want to do. Well, this whole piece of code over here deals with just getting the ships, right? This whole piece of code here is all about just getting the ships. So I'm going to cut that out of here. I'm going to go to my API and I'm going to create a function, all starships. I'm not going to take any arguments. I'm just going to break out that code. Let's paste it right into here and let's fix things. So first thing is I should at least have a module level doc. So I'm going to call it the SWAPI service. And then maybe, I don't know, you'd want to put something a little bit better than use for querying the SWAPI, the Star Wars API. Okay. I am going to need to import a few things. I need requests because I'm using requests in here. And I also need to import these exceptions, the timeout and the request exception. If I go back to my original code, I have it right here, right? So these two things essentially, right? That's in my main module right now. I'm going to import them here as well. So I'll just copy paste that. So we're good. Then what do I want to do? Well, let's just go through. So this is querying the API. So I'm going to replace that with a doc string. I'm going to say retrieves a list of all starships from the Star Wars API, and then return just, a list of starships. Actually, is it returning a list of starships at this point? It's going to return, we're adding what to that? We're adding the result. So yes, we are returning a list of starships, right? Or starship dictionaries, if you want to be more specific. Later on, I'm probably not going to do it in this video because it's going to get too long, but you would probably want to go ahead and use things like Pydantic, and you'd want to start putting type hinting and all that kind of stuff as well. But for now, let's start by keeping things simple. So we've got that. I don't like having max attempts and initial timeout as hard-coded values inside the function. So I'm going to do a few things while I'm refactoring. So max attempts equals, let's say 5. Then initial timeout, let's make that equal to 1 second. and I'll document that it's in seconds. So that takes care of that. Now this is always the same root, right? This over here. So let me go ahead and create a constant for this. Let's call this the base URL, because for the SW API, that base URL is always the same. And instead of me having to retype it, because I'm also going to need it in other places, I'm going to just interpolate it right here. So we'll say base URL, like so. So we're just going to, and that's why we get the squigglies, base URL, okay? So we've got base URL / starships, we've got requesting the request URL, the max number of retries. So this max attempts over here, I don't want this anymore, okay? I don't want the initial timeout to be 0.5. What I want it to be, and I guess this was 0.5, so let's make it 0.5. And actually I know that it really frequently times out. If we have just half a second, so I'll set it to 1. So my initial timeout, I'm going to take that out. The attempt number is fine. The current timeout is going to be my initial timeout, like so. Okay. Then the ships, we have that. The request, we have that. Okay, so that's fine. I'm also going to take this comment out. I'm going to hold or take that out. And I'm going to take that out as well. These are kind of, semi-meaningless comments. I can tell from the code what's going on. All right, so we're printing that if attempt number is greater than, well, max attempts now is a global constant. We'll do that. We exceeded the max number of attempts. That's fine. We're going to query the API. Okay, that's good. Current timeout times equals 2. Attempt number plus equals 1. Continue. Okay, I think all that stays as is. That's good. We get the data right from our response. It's JSON, so we get that data. We extend the ships. We check to see if there's a next page, and yeah, that's good. Only difference now is that I need to return ships, right? So let's put that in. All right, so we just factored that out from our main thing over here. So we took that out. Now, what did we take out? We took out, remember, that was ships, right? So if we go here, we can say ships equals, now I need to import this. So from refactor, well, actually from, what I'm gonna do is I'm going to go here and I'm gonna say mark directory as a sources root. And because I'm gonna run main, right? So this is gonna be a root. So I'm telling my IDE, hey, this directory is a root for when you're starting the application here. So it understands then the imports. Otherwise, it's going to put squiggly lines everywhere. So from services, right? So from services.swAPI, I'm going to import the API module as swAPI. Okay. So now that I've got that, and I really want to remove this. So let me go ahead and do that. Okay, now that that's gone, so now I'm going to use the swAPI, and actually, yeah, that's fine. So I could just import also the all starships inside, but that's fine because I'm going to need more from the API, so I'll keep it that way. So we're going to get our ships from the swAPI all starships service, okay? So let's try, this is all I'm doing for now. Let's go ahead and let's see if there's anything else we need to fix. Okay, well, yes, because we still have now for the film titles, we've got this max attempts that's over here. So we do need to fix that while we're at it. So this is for the film titles, all right? So I'm gonna grab all this code. And again, all that's doing is basically returning film titles, and then it's returning them sorted. So I'll keep that as well. Okay, so I'm going to cut that out, and we're going to go here, and we're going to create a new function. Let's call it def, and what should we call it? film titles. Now, film titles is going to need film URLs. I'll put that in a sec. Let's just paste the code in, and now let's fix things. So, film titles equals set. It doesn't like the fact that we have the same name, right? So that's right. So what I'm going to do is I'm going to change this. I'm going to refactor, and I'm going to rename this to results instead. Okay. So we need the film URLs, right? You can see the squiggly lines. We're missing that. So we're going to have to pass that in. We need to get the film URLs from somewhere and pass them to film titles. That's fine. Now, again, this initial timeout equal to 2. I'm going to take that out. We're going to make our current timeout equal to the initial timeout. So that constant that we created, we'll do it that way. So we no longer have magic numbers inside our code. If the attempt number is greater than max attempts, again, let's get rid of magic numbers. So everything else, I'm not changing the structure of this. I'm just basically putting it out into its own function. So I'm starting to this decomposition process. So everything else looks fine, and we're returning sorted results. Okay. So I think this is good. So film titles we need to call, and then we'll have to give it the film URLs. So let's go to the main one. You can see we have film URLs, which is a set. Will this accept a set film URLs? Yes, because we're just looping through the elements. We're iterating the set. That is fine. So here, what we need to do now is we need to put in the call to that, right? So the titles, because that's what we're getting back, is swapi.film titles given the film URLs. Okay, and in fact we can just return this. We don't even need to put it into a variable. We can just return it. So here's what's happening right now. We are querying all the starships. We go to the service. We're now doing this filtering over here. Okay, so we'll come back to this. And we're getting the film titles for those film URLs that we obtained by filtering the ships to the capacity and then just pulling out films from it. So this should work. Let's try and run it. So that's good. It's handling that, but now we've got this exception. Initial timeout is not defined. So I missed that somewhere. Ah, yes. Current timeout equals initial timeout. I didn't see the squiggle. Okay, let's try this again. I'll pause the video and then restart once it's finished. Okay, so it finished and we have our list of film titles, which looks the same as the first one that we had with the original code. Okay, so at the end of this refactor, the main function is already looking a whole lot simpler, right? If we go back and look at the main function over here, you can see that it's been trimmed down quite a bit by this decomposition. We took out all the code that we had for getting all the starships and all the code that we had for film titles. We made them into their own separate functions. This cleans it up quite a bit. But we still have several issues. For starters, the code in the main function has different abstraction levels. You remember I mentioned that in the beginning about having the same abstraction levels as much as possible at any rate in the functions. If we go back and look, here's what I mean. This is an abstraction where we get all the starships. And now we're dealing with the details of the starships to do some filtering and data extraction. And then we have another kind of very high level call saying get the film titles for those film URLs. This implementation here doesn't belong in the main starship films. That should also be abstracted out into its own separate function. So that's what I mean by different levels of abstraction. So I want to really have a function call to filter the ships. Now, the code also that we have in the servers for paging and query timeouts can be improved quite a bit. right? The code isn't dry. The individual functions that get the data from the API are difficult to understand because they mix things like retries and paging. So we'll have to fix that as well. So for refactor number 2, what we're going to do is just going to move the filtering logic out of the main function and it's into its own function. So I'm going to write a specialized function that both filters the ships based on the minimum capacity and just returns all the unique film URLs. Now that's a bit specialized, right? So you could argue that that should also be broken down into 2 separate functions. One to filter the ships and one to extract just the unique film URLs. This filtering function isn't really single purpose, right? If we do it that way. So I'm going to refactor that as well. Not only am I going to take that code out, right? So the code that's in here, not only am I going to take that out of the main function, but I'm not going to keep it as a single function. I'm going to keep that as 2 functions, one to filter and one to get the films, just to keep the functions single purpose. All right, so let's do that. Let's go ahead and create another directory. Let's call it Refactor 2. And again, I'm going to mark this in my IDE as a sources root. And I'm just going to copy everything over from the Refactor 1 into here. And PyCharm's been giving me issues with copying and pasting from one thing to another. So I'm going to stop the PyCharm IDE and come back to it. All right, let's try this again. Nope. All right, I'm going to switch to my file explorer. Well, on the Mac, it's called the Finder. And I'm going to copy the files in there since PyCharm is refusing to cooperate. Okay, so now we have that copy. And let's take a look at this code. This is what I want to take out. So I'm just going to copy it. I'm not going to cut it out quite yet. And what I'm going to do for that one is I'm going to create kind of a utils thing over here, because it's not really part of the service. I don't want to make this filtering part of the service. It's really not. So in here, I'm just going to create another Python file. I'm going to call it utils.py. And let's give it a comment, or a docstring, I should say, various utility functions used in this app, in the Star Wars API app. So let's call this def films for min capacity ships. And we need to give it the ships and we need to give it the min capacity. Okay. So right now I'm just going to extract the whole thing as a single function. Right. So we probably need to put also a docstring in here. Determine films in which ships of a minimum capacity appear. Right. Something like that. The param ships should just be a list of ship objects, right? They're actually dicts because they're just coming back from JSON. If it was pydantic, we'd probably have a pydantic model here. The min capacity, the minimum capacity, inclusive of each ship. And what is that going to return? It's going to return a list of film URLs, right? We're going to get those URLs back. And so we get this, and I said we're going to return a list. So I'm going to return list film URLs, like so. Okay, so that's kind of the first way I would do this. So now if we go back to the main API, all I need to do here is to say film URLs. Well, before I do that, let me go ahead and change my imports. I need to add from utils. I'm going to import. And what was it called? It was called films for min capacity ships, like so. So I'm going to replace all this thing by saying, well, the film URLs, right? That's what we're returning from min capacity ships. So films For min capacity ships, we need to pass it the ships and we need to pass it the min capacity, right? Which we have over here. Now I'm going to actually use named arguments. So min capacity equals, like so. Okay? And all this now is gone. There we go. So we can basically make our main function like so. The ships, get the film URLs, get the film titles from the film URLs, and return that. When somebody reads this at the top level, it's very easy to understand what this is doing, right? I'm getting all the starships. This one is a little bit different, right? The films for min capacity ships. That one, yeah, that's a little harder to describe what it actually does. But you can go ahead and just go take a look at it, and it determines the films. See, got a typo, in which ships of a minimum capacity appear. Okay, fine, I get it. Now I can go back. And then what does it do? Well, it gets the film titles from the film URLs. Again, easy to understand what's going on. Okay, so that's one step better. I do want, though, to go back to this, and I want to break this up into two different functions. I don't like the fact that this is doing both the filtering and the extraction of the data. I probably want to have this as two separate functions, and yeah, I'm going to do that. So let's go ahead and create another directory. Let's call it Refactor 3. And I'm just going to copy the code from Refactor 2 inside that directory, which it doesn't let me. So I will go back to my Finder and do that in there. Okay, so now I've got that code. And all I really want to do here, well, first, I'm going to mark this directory as a sources root. And then in the utils, I want to make some changes. So I want to create a function called filter ships by capacity. I can type capacity, and I need to pass it the ships and the min capacity. Okay, it's got a single purpose. Right, this is why this one was difficult to document, because it didn't have a single purpose. It was doing two things. Here, this function, that's very easy. It's going to filter the ships by capacity. End of story. Right? So I'm going to put in some doc strings to save some typing. I'm just going to copy that from the repo. And what I'm going to do here, I'm going to go for ship in ships. And I'm going to kind of do what I had over here, right? I'm going to try. I'll keep that. I'm not going to change that at this point. I think it's fine. There's probably better ways of doing this. Maybe we could do a comprehension. So I'm actually just going to take this code and paste this in here. So what I'm going to do, though, Okay, let's just put the code in and let's strip out what we don't want. Okay, so I don't want this. I don't want to put in this thing over here. And if we can't find, the cargo capacity, then we're going to continue. That's fine. But what I want us to do now is say if the cargo capacity is greater than or equal to the min capacity, what do I want to do? Well, before I was adding it to the film URLs. But what I'm going to do in this case, I don't really care about having a set necessarily. Okay, I'm not returning film URLs, right? I'm actually just returning ships. So for ship in ships, I could, I guess, create like, a results list maybe, and then append that, and then finally return the results. But why do that? I can just use a generator. So if my cargo capacity is greater than or equal to the min capacity, yield the ship. Very simple. So this is why in here I said this is going to be a generator of ships. Okay. Got one too many lines over here. That's why we get the squiggles. All right. So this filters the ship by capacity. The next thing I want to do is say extract the film URLs. And for that, I'm going to get basically ships from there. I'm going to pass in ships, I should say. So again, we need to put in a doc string. I'm going to copy paste that. Need 2 spaces. And what do we want to do here? Well, we're going to iterate for ship in ships. And if you looked at what we had before, we were doing this set, right, of film URLs. I'm not going to worry about returning a set and doing the deduplication in here. Here, what I'm going to do, I'm going to loop through every ship in ships, and I'm going to check to see if ship.getFilm. So I'm not doing a check to see if the film key is in the ship. I'm doing a check that not only is it in there, but it is also not empty. And if it's not empty, what am I going to yield? Well, I want to yield every film, right? Because ship films, which now I know exists, so I can use square brackets, right? But what is that? That's a list. So I'm going to yield from that. So again, I've got a generator. So yes, I could potentially get duplicate films coming back out of this generator. But instead of this function making the decision that I'm only going to give you unique values, it's saying, no, I'm going to give you everything I have. If upstream, whoever's calling extract film URLs, if you want to make this unique, then you go ahead and make a set out of it, and make it unique, or use any other technique that you might want to use. So all this now can go away. We've replaced it now with these 2 single-purpose functions. So now, of course, we need to change our main API. So if we go here, we no longer have this, right? We no longer have this films for min capacity ships. Instead, we have the extract film URLs function, and we have the filter ships by capacity function. So this goes away. So what do we need? Well, we need, first of all, the filtered ships, right? That's the first thing we're doing. So we're going to filter ships by capacity. We're going to pass it the ships and the min capacity. Okay. And again, I probably should use named arguments. It doesn't really matter in this case because it is so obvious. I remember exactly which one comes first in the positionals, but this might be better practice. Now that I've got that, I need to extract the film URLs from those filtered ships. Well, the film URLs is equal to extract the film URLs from the filtered ships. Okay, so at this point, remember, this is a generator. This is also a generator. Now, I could pass the film URLs to film titles. If we look at that, film titles is just going to iterate through the film URLs. But in this case, I really do want to deduplicate my filtered ships. So I am going to make a set out of it. So the set is going to run through extract film URLs on filtered ships, and that itself is going to iterate through filtered ships, which is this generator over here. Okay? And that's it. That should be it. So we should be able to run this and hopefully get correct results. So again, I'll pause the video while we let this thing run. Seems like the SW API is a little slow tonight. Okay, so there's a bug. I'm not getting any output, so something's wrong. Let's go back and take a look. Well, first of all, we can clean this up. We don't need this in here anymore. So let's take a look. Filter ships by capacity. We do accept, continue. So we go in there, and then if cargo capacity yield ship. That seems right to me, I think. That's right, for ship and ships, right? Ships, min capacity. Then to extract the film URLs, we yield from the ship films. Films. That's a typo there, right? And this is why, by the way, using Pydantic is much better. You don't get into situations like this. Okay, so let's try it again. And let's see if we should be requesting our starships and then the multiple pages. And it's really slow. Okay, we finally got the first page. Now we're trying the second page. Got it. Third page. All right, I'll pause the video and come back. All right, so that worked, right? Here again, we have our list of movies. So that was refactor number 3. Now, one note here is I could have made the filter ships by capacity more generic. I could have said, filter ships, and then I could have passed in a predicate function the same way that the filtering function in Python does it, right? So if you want to do it that way, that's fine. I decided not to for here. And then, of course, note how the filtering and extraction functions are not creating yet more lists in memory, but instead we're starting to leverage generators. Again, that's also more Pythonic, right? Okay, so for refactor number 4, it's time to turn our attention to the API service. Our functions in there do 2 or 3 things. They do paging if it's needed, they do the timeout retry handling, and they actually query the Star Wars API. Now, paging we only need once, but timeout handling we do twice in the code, right? If we take a look at the code in the API, so let's look at the services API, you can see that we're doing this timeout handling, number of retries, max attempts, current timeout. We're doing that twice. We've got the kind of the same code, right? 2 times. Here, we've also got paging. We only use paging once. We only need it once, but it's still kind of mixed in with everything else. Remember what I said, the main piece of the code here is this and this, right? And everything else is about paging and timeouts and so on. So this is why this function is really difficult to understand. So we're going to refactor that. So let's go ahead and let's create another directory, refactor 4. And I'm going to go copy the code from refactor 3. Okay, so let's actually close all this stuff and let's go back. So here's our main. That's not going to change at this point. Now we're really going to be looking at the services, which let's reload from disk. There we go. Okay. So we really want to take a look at simplifying this. So we're going to do this a few steps at a time. We're not going to do everything at once as usual. So we're going to start by stripping away the timeout handling and focus on the paging first. Then we'll come back later and put the timeout handling back in again. Okay, so how we're going to structure this. What I'm going to do is I'm going to separate out a function that queries all the pages for the starships versus a function that queries a single page for a starship. I decided to do it that way. I don't know if that's the best way, but I figured, okay, that's, I think, going to work. So what I'm going to do is I'm going to define a function called starships, okay? And starships is going to basically receive as an argument the request URL that it needs to use. So again, I'm just going to put in the docstring and I'm going to put a print statement. So again, I'm using print statements to basically kind of log things. What I really should be doing is using logging, but I don't want to overburden this video. It's already going to be extremely long. So response equals requests dot get, right? We need to get this, do this get request, and we'll say request URL. That's the request we want to send, and we need to specify our headers. So our headers was, and I think I've got them down here somewhere. Let me go grab them so I don't have to retype it. And I'm going to leave out the timing for now. So I'm not going to set the timeout. Okay, so I'm going to leave that undefined, which means it shouldn't time out unless it goes beyond whatever the default timeout is in the requests library. So now that I've got that, what I want to do, I'm not going to do any error handling. If this thing fails for some reason, I'm going to let the exception bubble up and I'll worry maybe about the exceptions later. But I also want to make sure that I raise for status. So if I don't have a 200 level kind of response from the API, I want to make sure that an exception is raised. And again, I'm going to let that just bubble up. Okay, so I've got one page. Now I need to get my data. So I'm going to take the response.json. Then I'm going to say the results equals data dot, and I'm going to use a get, right, to get the results in this case. Again, Pydantic would be so much simpler. And then that's my actual results. That's the ships, right, in that page. If we go back and look at the documentation. So if we go back and look at starships, you'll see that what we get is, well, that's for a specific starship. So let's go ahead and make this call. We'll do that in the browser. So let's go ahead and just call the first page of starships. So you see that we get this entry called results. That's what has all the ships in it. We also get this next. This next tells us if there is a next page. And if there is, it populates it with the API request that we need to make to get the next page. So this is an API that kind of documents, you know, other entities basically in this API. And that's a pretty common approach to writing APIs. Okay, so we are interested in the results and we're interested in next. Okay, so if we go back to the code, so we get the results from the results. That's the one thing. And then the next page is going to be data.get. Again, just in case the key is not there. And then we'll default it to none. And if the key is there and there is no next page, it will also be a null value in the JSON. And so we'll get none as well for that. So next page is going to tell us exactly whether we have a next page or not, based on whether the next page is none or not none. And then all we need to return here is the results and the next page. I also need to know that there is a next page or not. So you can see this function has a single goal. It basically requests this URL through a get, and it just comes back and says, here are the results, and here's the next page. This doesn't have to be starships. It could be anything else, because remember, we're not actually, you know, specifying starships in here. I'm calling it starships, but really we could call it something a little bit more generic. But since I'm only using it for starships, I'll keep it named that way for now. We can always come back later and refactor that. Okay, so now we need to do get all starships, right? So what we're going to do here, we're going to take all this out, right? We don't have to worry about doing the get. We don't have to worry about extracting the data. We don't have to worry about the timeouts. We said we were going to take that out. We do have to worry about the paging, however, right? So before I take everything out, here's what I want to end up with, right? I don't want all this stuff. What I want to be able to do is to call a function called paged, and I want to pass it the function that I want to call. That's going to be the function that returns a single page. So in this case, that's my single page function, right? That I called starships. I could have called it something else. It doesn't matter. And I also need to tell this paged function that we haven't written yet, I need to tell it what's the starting page, because that's all I need, right? If we look at the documentation, or if we look at the output here, once I have this first page, the next page is given to me here in the next. So I don't need to know anything else about how to page. I just need to know how to get the first page, and the API itself will tell me how to get to the next pages. So all I need here is really just the starting point, right? What should the starting point be? Well, the starting point is this. This is how I get page number 1. So I'm going to want to call starships with page number 1. And then I want this paged function to then say, well, let's look at the results of calling starships with this first page. And if there is a next, well, call that. And if there is a next, call that. And if there's a next, call that, until it has paged everything. So I'm going to want page to be a generator, because I want it to basically loop through the pages. right? So we'll get back to how we're going to deal with the output of this paged function, but let's go ahead and write it. So we can go back to the API over here, to the package, and I'm going to create a new file, and I'm going to call that page.py. Okay. Actually, let's call it paging. Paging. Let's refactor that, rename paging.py, and I'm going to go ahead and copy paste the doc string, and I'm going to create a function called paged. So remember, it needs to take in that single page function, right? The function that's going to be used to call a single page, and I need to tell it what the initial request URL is. So what are we going to do with this? Well, what I want to do is I'm going to set a variable called next request URL equal to the initial request URL. So I'm going to start with that. And the reason I'm doing this is because I want to do a while loop. And I want to say while there is a next request URL, okay? So initially, the first time this paged function, when this page function first starts running, next request URL is set to the initial request URL, right? So to the Starships page number 1. So this is basically not none. So while that's true, I'm going to get the results, and I'm going to get the next page URL from calling the single page function with my next request URL. Okay, again, let's take a look at this side by side. But if you look at what the Starships function is, right? Because remember, this is what we're passing to the paged function over here. We're passing it Starships, and we're passing it this URL. So it's going to call Starships with the initial request URL, which is page number 1. What does it get back? It gets the results back and the next page from this function. So that's my expectation for paged, is that this should return the results and the next page as a tuple. I probably should use a name tuple here, but I'm not going to for now. Okay, so we're getting the results and the next page. Now, what do I want to do with the results? Well, I'm just going to say yield from results. I don't need to do anything else, right? And once I've done that, what do I need to do? Well, nothing. The next page URL has already been populated, so it's going to do the while again. If the next page URL came back populated with, let's say, page number 2, well, it's going to run it. It's going to call that function with the URL for page number 2, and then we're going to yield the, all the results that came back, and then we're going to continue until we get no next page. And that's it. That's all we need. Okay, we need 2 blank lines. Okay. So that's our paged function. That's it. That's all that was actually needed. So now let's go back and take care of this here in the API. So paged is doing what? It's returning, basically, it's a generator. It's yielding these results one by one. And what do I want to do with those Starships that I'm getting back? I want to yield from that as well. Now I need to import paged. It doesn't know what it is. So let's go ahead and say from, and this is the services.swAPI.paging import paged. Okay, so again, I need to remember to set my root over here. And this is why I was getting the squiggles in here. Okay, that's gone. Python would understand it fine. It's just that the IDE gets confused. Okay, so we've imported paged from there. We are yielding from that, and all this code, all of this goes. That's it, right? We've done what we needed to for the Starships. Now I'm going to leave film titles as is because we don't have any paging in there. And we'll take care of the timeout retries in the next refactor. So given all this, we should be able to run that. So let's try it and see what happens. Again, I'll pause the video and come back, either if the thing crashes or if it completes. Okay, so I stopped it because we have a problem. You can see that it's running this query and it's the same query again and again and again. So it's not somehow incrementing that page, right? It's not taking that into account. So let's go back and figure out what's going on. So let's first take a look at the paging. So let's just make sure our logic is correct. The next request URL is the initial request URL. While the next request URL is not empty, we get our results and the next page URL. This is my problem. Next request URL from the single page function, and then return the results. Okay, because what was happening, it was creating a new variable called next page URL, and next request URL stayed as starships the whole time. Okay, so let's try this again. Okay, that seems to be running. Now we're requesting the films themselves, so we know we didn't change any of that code, so we should be good. And in fact, there we go. We have the correct output over here. All right, so that's great. So now we're going to, in refactor number 5, we're going to look at the timeout retries. And we should be able to do this one with a decorator pretty easily. Now, also notice that I am systematically removing any handling for exceptions that I can't really do anything about. Now, later I might come back and decide if maybe I want to do some handling, like maybe if a film isn't found. For now, though, I'm not going to do any kind of exception handling at these kind of lower levels. I'll let the caller decide what they want to do. And then later I can come back if I have time and start refactoring that as well and layering in some exception handlers. Okay, so we're going to, let me kind of close all these things down, close everything here, and I'm going to create another one called Refactor 5. We're going to mark this directory as a sources root, and I'm going to go and copy Refactor 4 into Refactor 5. Okay, I copied that. Let's reload from disk. Okay, so what I'm going to do here is I'm going to create a new module called retries.py. And let's take a look at the API. And we want to basically retry this requests.get. That's the function we want to retry. And if you look at the film titles, it's the same thing. It's this thing that we want to retry if it times out. And we want to change the timeout, increasing that every time it fails to some larger timeout. So what I'm going to do is I'm going to write a function that is going to decorate this requests.get. Now I won't be able to use the decorator syntax for it, but it's still going to be a decorator function. And I want to decorate this function here inside the film titles and inside this starships at this level over here, right? So I'm going to want to decorate the get method, or the get function to be more specific, to be more correct, and I want that to handle the timeouts and the retries. So let's go ahead and actually write that. It's relatively straightforward. So let me just paste the utilities, the doc string, and then we're going to need these exceptions from the requests library. We need the timeout and then the request exception. And we're going to write a decorator. And this is actually going to be a decorator factory, because we want to pass parameters to it. And I have a video on decorator factories in this channel if you want to take a look at it. Okay, so what do we need for the factory? Well, we need to know what's the maximum number of attempts and what's the initial timeout, right? So maybe 5 max attempts, an initial timeout of 2 seconds or 1 second, whatever we want to make that. And again, I'm just going to copy paste the docstring, so we don't spend time on that. And what do I want to keep track of here? Well, the temp number, right, is going to be equal to 1, and my current timeout is going to be initially my initial timeout. Okay, like so. Then what do I want to do? Well, I can't run anything right now, right? There's no function here that I can call. But what I'm going to do is I'm going to create a decorator. So I'm going to define this decorator. The decorator is going to receive the function that I want to decorate, that get method, right? That get function. And of course it's a decorator, so it needs some inner function, and it's going to take in basically the standard stuff that we have. And I'm going to specify non-local for a temp number, and also need non-local for the current timeout. Then I'm going to do that while loop, right? While true. So I'm going to try, and I'm going to try, well, to do what? I'm going to try to call that function that I'm decorating, right? That I've just decorated, passing it the arguments that were passed to it. Whatever was passed to it, I'll just, or whatever was passed to it when it was called, I'll just pass that to the original function. But what I'm going to do is I'm going to basically inject the timeout, which is a parameter, an argument that is understood by the get method, right? That we're going to decorate. It's understood by the post method as well and everything else. But it's understood by the get method, which is specifically the one that we're going to decorate here. But it will apply to other methods as well, to other, post and patch and put and everything. So we're going to set our timeout to the current timeout. So what am I doing with this decorator? Basically, I'm saying, well, you're going to decorate the get function from the request module. You're going to call it with whatever arguments, it was called with, but I'm going to inject this timeout in there. And if this works fine, then just return the result. Return the response, basically, from the request's get, or the request's, method, HTTP method. I don't mean this is a class method, because get, post, etc. are actually functions. But from an HTTP standpoint, these are different methods: get, post, put, patch, etc. Okay, so that's going to work. Now we want to catch, however, the timeout exceptions. So if we have a timeout when we call this, we want to say if attempt number is greater than or equal to max attempts, then we've reached the maximum number of attempts. And there's not much that I can do here, so I'm going to raise a request exception, and I'll put in a custom message, max attempts exceeded. Again, just doing what I kind of mentioned, that I'm pulling out some of the exception handling, because I don't know what to do with this, right? I exceeded the maximum number of attempts. What should I do? Well, this decorator doesn't know, right, what the logic should be. So it's saying, well, I'm just going to raise an exception, and whoever's calling me can handle it if they want. Okay, so that's that. But if we haven't reached the maximum number of attempts, then what? Then we need to set the attempt number plus equals 1. So remember now, this is a free variable in the closure, and this is why I had to make it non-local, because I'm assigning to it. So I need to make it non-local, and then I also need current timeout, and I want to make that times 2, whatever it was before, times 2. Now I'm going to do some logging, quote unquote. I'm just going to print, and here I'm just going to copy paste, just so I'm not wasting time with the print statements. Okay. And that's it. So now we just need to finish up our decorator. So we're going to return inner, which is the decorated function. And then of course we need to return the decorator, since timeout retry is a decorator factory. So we need to return decorator, like so. Okay, so that's for doing the timeout retry. It is a decorator. Now let's actually use it. So in here, what we have to do now is we have to decorate the requests.get. Now, you might think that you could decorate it outside of this, but if you look at what the retries is doing, it's basically capturing the attempt number and the current timeout. I want this to be reset every time I make a new GET request. I don't want that to be shared amongst all my GET requests. So I need to do my decoration of the request GET inside this function here, because this is the one that gets called once for each page, right? So what I'm going to do here is I'm going to decorate it. Now I cannot use the @syntax decorator because I'm not defining the function here. It's already defined. But as you know, that @syntax is just syntactic sugar. And instead, we're going to decorate it the long way. So, the real way, basically. So we're going to use timeout retry. Now we need to import that. We don't have that yet. So from, and let's do it here, paging retries. So from services.swappy.retries, we're going to import, what was it called? It was called timeout retry. That's the decorator factory. Okay. So here we're going to decorate what? Well, it's a factory, right? Timeout retry is a factory. So I first have to pass it whatever I need. So max attempts equals max attempts, and initial timeout equals the initial timeout. Okay, so now that I've called timeout retry, I have a decorator that got returned from timeout retry. Remember, timeout retry is a decorator factory. It's returning the decorator. Now that we have the decorator, we can decorate the function that we want. In which case, or in this case, it is the requests.get. This is the function we want to decorate. And so now we have essentially the retry, the timeout, and the retry handling done. That's it. We don't need to do anything more other than over here, we need to use the retry get. We need to use the decorated method, okay? Or the decorated function. And then everything else stays the same. So now we can go into the film titles and essentially do the same thing. So let's take out what are we actually doing, right, for the film titles. Well, we're going to need to break out the film titles from the film title, right? We're not doing paging, but we still have to handle more than one request, right? We have to do the request film URL in film URLs. So let's go ahead and write the function for a single title. Again, just breaking things apart so that functions have a single goal in mind. So the goal of this function, film title, is to get the title for the film URL. So again, I'm just going to copy paste the docstring and the log info. I should be using logging. I'm not, just to keep this a little simpler. So what do we want to do? Well, we want to do this, right? We want to get this thing over here. So let me go ahead and just paste this in. This is what we want to do, right? But we want this to be under the retries. Well, we know exactly how to do it because we just did it here, retry get. So I'm just going to copy that code and go ahead and put it here. So now we have our decorated requests get method, so we can use it right here, say retry get. And the current timeout, well, we don't need that in there anymore because we're giving our initial timeout over here, and we know that the actual timeout is going to get injected by the decorator. So we just need the film URL and the headers. We still need to get our raise, we get our response from that. We still need to do a raise for status, and we still need to extract the data that we need, which is this over here. And it's only getting one title because it's only doing one film URL, so I can basically just return this. Return data.getTitle. That's it. So this function has a single purpose in life, which is, well, it's a timed out retry get. Okay, so it's relatively high level. Then we do the get itself. It's easy to understand. We raise for status, we get the data, we return it. Very straightforward. And now all this mess gets simplified. We take all this out. We don't need any of this stuff. What are we going to do for film titles? Well, we're going to say for film and film URLs, what am I going to get? I'm going to get the film title for the film URL. I'm going to call that function. I'm getting what back? I'm getting a title back. What do I want to do here? I'm going to yield it. Again, I'm going to use a generator. Instead of building up the list here or a set here or whatever, I'm just going to yield it, and I'm going to let the caller decide whether they want to sort the list, whether they want to duplicate the list potentially, and so on. And we're going to put in the docstring as well. So let's do that. And I put it in the wrong place, of course. Okay, now let's go back and look at our main, and let's see if we need to change anything there. So I'm calling the film titles. Remember, I just changed that, film titles. That's going to be a generator with the films. So if I look in here, I'm just returning that from the Starship films. And then what am I doing here? I'm just iterating through them. Do I need to worry about maybe sorting them, making them unique? Well, the films I've already made, the film URLs are made unique, so the titles should be just fine. There should be different titles for different films, right? So if I look at that, probably what I'd want to do is maybe just make them sorted. So I will sort that. Sort will take any iterable. So even though film titles is essentially a generator, sorted will iterate through that, and it will generate a list, but that will be a sorted list, and by default it's going to sort by the string, the title, right, of the movie. And then we're going to iterate through that and print the films out. So that's it. I think let's go ahead and run this and see what happens. Okay, so it finished the paging with the, and you can see now we also had the attempt, so we had a request timed out, and so we had 2 attempts on that, so that seems to be working correctly. We do have, we're also doing the paging correctly, and we also have the request timeout retries. And at the end of the day, we get our list, and it's in alphabetical order. So we went from this over here, which is very difficult to understand, to, yes, a more complex application. We have different modules and so on, but look at how easy it is to understand each of those functions. Get all the starships, filter them, get the film URLs, get the film titles for them. That's it. Done. Now we look at the API. How do we get all the starships? We just do a paged view of starships. So what is starships? Well, it's basically just doing this, and it's doing it with the timeout retries. But all that logic has been abstracted out. So now when we look at a function, we can really focus on what the function does, as opposed to some of the plumbing work like the paging or the request retries. Same thing with film title. Much easier to understand what's going on here, right? Even if we don't understand what timeout retry does, we kind of understand that this is a decorator factory that abstracts out timeout retry logic. Okay, so maybe I don't quite understand this as someone new coming in and reading the code, but I understand what it's supposed to do. And then it's like, okay, let's say I know what it's supposed to do. I don't get it, but okay. And then what does it do? Okay, well, it's basically doing this get on the film URL, and then it does a raise for status. That I understand, this I understand, right? You see now that it's much simpler to understand this program. Yes, it's been decomposed into smaller chunks. and we've put it into various modules and tried to structure our application in a better way, and in a way that's going to allow us to grow it as well with more things and more functionality. Okay, so some parting thoughts. At this point, I'm not entirely happy with how I implemented the paging and the timeout retries. There might be a simpler way of doing it or a cleaner way of doing it, but that's all I could come up with, and I didn't want to spend hours trying to, refactor everything. So I may come back to it, and this is something that would happen, if you're working on a project for a company. You don't have forever to refactor a piece of code. You have to do things pretty quick. So you're looking at diminishing returns, and you're trying to kind of do, the 80-20 rule, saying, well, I'll do most of what I think I need to do for refactoring right now, and then I'm incurring some technical debt, but I'll come back to it at some point, maybe in the future, or somebody else might, right, if they're looking at the code. I would also like to add some more structure for the various data sets and the various data models that are being returned and passed into various functions. So probably a mixture of pydantic, maybe some name tuples, type hinting, that kind of stuff. Now, I don't type hint everything in my Python code, and I know that some people might object, so you're totally free to take a different approach. I don't. I tend to type hint things that are necessary in order to really explain what a function does in terms of what are its inputs, what's the output. It also helps the IDEs with autocompletion to understand that, okay, if I call this function, I'm getting this type of pydantic model back. So now when I type, the instance dot, it will actually be able to tell me what are the possible field values for the pydantic model. So those kinds of things. So I use it where I think it's necessary. Other refactoring I would consider before putting something like this in production would be to take a closer look at the exception handling. As you saw, I kind of pulled everything out. I think there is some exception handling that could be done that we had actually initially in the original code, and I just took it out. But like if you're trying to query a film title and you just don't get the film title, do you really want to break the entire application? Or do you want to skip it, put out a log record saying, film not found, but continue and at least provide the remaining titles that, you were able to come up with. So those kinds of things. There are maybe some things where we can do some exception handling. Also, as things are, I use print statements to effectively, I'm logging information to stand it out. That's bad practice. Instead, you should be using, proper Python logging. There's a logger module, very simple to set up. And when you use things like Python, I think Flake 8, if you look at my videos on Flake 8, if you have print statements, it won't pass Flake 8 if you enable that rule, which I do, and most companies do. So if you try and put in code into a Git repo and it contains print statements, it will fail and you won't be able to do a merge. And then, of course, more important than even all this, additional refactoring that I'd like to do is testing. There is no way that, in most companies, when you're working in a software engineering team, there is no way that the code that I just showed you would make it into production without comprehensive unit tests, at the very least. You may have also integration tests, end-to-end tests, and things like that, but at the very least, you need unit tests. And I don't have any, of course, because it takes time to run tests. It is part of writing good code in any language, not just Python, by the way. And so most of the stuff that I showed you here, we used Pythonic things like decorators and generators and things like that, but the idea behind decomposition is not unique to Python. This is just something you should be doing in any other language that you're using, be it JavaScript, be it Java, C#, C++, whatever it is. You try and keep your functions or your class methods small, compact, very goal-oriented, and so on. All right, so this was a long video, but hopefully you found, this refactoring exercise useful. So thanks for watching, and please leave comments and tell me what you thought. And if you do want me to take this to the next level, then, if you click the thumbs up on the video to tell me you liked it, and leave something in the comments saying that you want to see more of this refactoring, then let me know. Thanks for watching.